Okay, so today we are going to discuss principles of discretization. What is meant by discretization here? Because we know that all the industrial processes are continuous in nature, continuous time form, and we are applying here digital control, and where process is our control is our digital, whereas process is continuous. Then we need certain methodology for conversion of this continuous time form to discrete time form. So, there are 4 methods given which will convert continuous time form function to discrete time form, and in continuous time there is S plane, whereas in discrete time Z plane, right. So, we can say that the discretization is basically a mapping of S plane to Z plane, right. So, there are 4 methods. One is step invariant discretization, second is impulse invariant discretization, and third is discretization based on finite difference approximation of derivatives. And fourth one is discretization based on bilinear transformation. Bilinear transformation. With these 4 methods, we can map S plane to Z plane, and out of these 4, this discretization based on finite difference approximation of derivatives as important one. Similarly, this one also. So, let us start with this one, discretization based on finite difference approximation of derivatives. Finite difference approximation of derivatives. Now, what is the meaning of this finite difference derivatives? See, in differential equations there are terms like yk, yt. If we take an analog continuous time form, yt dy by dt. Okay. So, if there is any derivative term in differential equation, for this one, this is a derivative. So, this method says that this can be approximated by a finite difference of consecutive samples. One sample is suppose yk, another sample is yk minus 1, okay, or yk plus 1, right. So, yk plus 1, yk minus 1, these are the consecutive samples. So, finite difference of these one, that is this method, finite difference approximation of derivatives, means we will replace this derivative function by finite difference of consecutive samples, right. So, let us see with an example taking first order differential equation. First order differential equation dy by dt plus ayt equals to RT. This is the first order differential equation. Now, in this category also there are two methods. One is the backward difference method, another is the forward difference method. So, let us discuss first A, backward difference method. According to this method, it says that replace yt by yk RT by RK and derivative of dy by or dt equals to yk minus yk minus 1 upon t. That is the finite difference of consecutive samples according to this method. So, now by using this backward difference method, we can rewrite this differential equation as yk minus 1 upon t plus a.
Sir, what is capital T?
Capital T is the sampling time.
Sampling time.
Yes. A here yt equals to yk equals to rk. Is it clear?
Yes.
Now, our objective is to map S plane into Z plane. Then for continuous time we will take Laplace transformation, and for this discrete time equation we will take Z transform. Okay. So, by taking make it equation number 2. So, by taking Laplace transformation of equation 1, it will be S ys plus a ys equals to rs, or ys s plus a equals to rs. So, ys upon rs equals to 1 upon s plus a. Now, take the Z transform of equation 2. Z transform of equation 2. that is yz minus z inverse yz upon t plus a yz equals to rz. Now find out yz over rz. Find out yz over rz. One upon 1 minus z inverse yz taking out 1 minus z inverse upon t plus a, right, it is in denominator. Is it clear? सभी के आ गया? Okay, now compare these two equations. So I can write here gs, I can write here zz, right? So from this equation I can write zz equals to gs at s equals to 1 minus z inverse upon t. Compare this 1 upon s plus a, here 1 upon this factor plus a. So gz equals to gs at s equals to 1 minus z inverse upon t. So we have got a relationship between s plane and z plane, right. Now next point is of stability, that may be possible system at continuous time is stable, it may not be stable in discrete time system, right. So we have to analyze stability part now. So we know that left half S plane is stable if poles are there, right. So we can write real part of S less than 0 for stable. System to be stable, we can write real part of S should be less than 0. So I can write here 1 minus Z inverse upon T less than 0. Or Z minus 1 upon T Z कर सकते हैं, ओके. और I can write Z minus 1 upon Z, it is also less than 0. Right? Now, Z is a complex variable basically. So, taking Z equals to alpha plus J beta. Now, put the value of Z here, alpha plus J beta minus 1 upon alpha plus J beta. Is it clear? Now, I have to take out only real part. So, for that multiply this term whole term by alpha minus J beta. So, solve करिए इसको. So, we can write this one alpha minus J beta upon alpha plus J beta alpha minus J beta. Then separate out real and imaginary part. So, imaginary part we are not interested, and real part is minus alpha plus beta square upon alpha square plus beta square less than 0. Clear? Now, I can write it as alpha minus half square plus beta square less than half square. Do it? Is it coming? Alpha minus half, this alpha square minus alpha plus beta square less than 0, right? Then I am adding quarter here, then it will be alpha minus half square plus beta square and less than it is half square. Now, we know that this is the equation of circle,
a square plus b,
right? And coordinates of circle are alpha equals to half, beta equals to 0 and with radius half. This is radius. These are the coordinates. Any doubt so far?
No, sir.
Okay. So, now we can map this S plane into Z plane. This is our S plane and this is stability region, right? And this is our Z plane with unit circle, right. So, if it is unit circle and it is radius half and coordinates are alpha, see Z equals to what? Alpha plus j beta, right. So, where will be the center of this circle? This one, right. Alpha half here, beta 0 here and radius half. It means there is a small circle inside this. Is it clear?
So once more.
Once more, okay. Coordinates of this circle is alpha equals to half or beta equals to 0. See here, alpha is the real part and beta is imaginary. So, in this Z plane, this is alpha and this is beta. So, alpha half is here because it is 1, it is a unit circle basically. Unit circle means its radius is 1. So, if the radius of this circle is half, then its center is here. Is it clear?
Yes, sir.
Then we can say that left half S plane is mapped into a small circle with radius of half and which is inside the unit circle. So, that is why we can say that if we go for backward difference method for the discretization, then if the system is stable in S plane, then it will also be stable in Z plane. Clear? Any doubt? हाँ, यही condition है. If in Z plane, if any poles are coming outside the Z plane, then it is last term पे हमने देखा Weber stability, in which if the poles are here then it will give a diverging response, and while response should be converging in nature. Then it means it will give a stable mapping. Okay. So, this is backward difference method. Some problems are also based on this backward difference method. We will solve after completing this topic. Next is the B part of this one, is the forward difference method. Right. So, according to forward difference method, again y t is replaced by y k. Again we are taking differential equation here. Now y t will be replaced by y k, r t by r k, and derivative according to this method d y t upon d t equals to k t, it will be y k plus 1 minus y k upon t. This is rule, forward difference method rule, y k plus 1 minus y k upon t. Now, put these values in differential equation, this one. So, we will get y k plus 1 minus y k upon t plus a y k equals to r k. Now, take the Laplace transform of this equation, that will be same as previous. So, G s, that is y s upon r s, will be 1 upon s plus a. एस वाई एस हो जाएगा इसका, एस वाई एस प्लस ए वाई एस इक्वल्स टू आर एस. सो जी एस विल बी वाई एस अपॉन आर एस, that will be 1 upon s plus a. Now, take the z transform of this equation. So, it will be z y z minus y z upon t plus a y z equals to r z. So, we will solve it for y z upon r z, that is z z. It will be z minus 1, z minus 1 upon t plus a. Clear? This z minus 1, y z is taken out, z minus 1 upon t plus a, this is the denominator. Now, again we can write that g z can be written as g s at s equals to z minus 1 upon t. So, this is the mapping relationship between s plane and z plane while we are using forward difference method, right. So, s here is z minus 1 upon t. Now, again we have to analyze stability? Stability is real part of S should be less than 0 for left half S plane. Now, here real part of Z minus 1 upon T less than 0. So, it is real part Z is less than 1. Now, no need to put here alpha plus j beta. It is clearly indicating that less than 1, it is whole
Unit circle.
less than 1 part is coming inside the Z mapping. So, let us see, this is our S plane, sigma j omega and this is the unit circle then this less than 1 means circle के अंदर आएगी but this part is also included here, this one. Suppose any pole is here, it is also fulfilling this criteria less than 1. So, there are chances that a stable S plane may map outside the unit circle. It is not necessary always. See, this is the stability region now. This is Z, it will be less than 1. So, here if it is here, if it is here, it is fulfilling that criteria, right, less than 1. Suppose any pole is here, it is having value of alpha less than 1, but it is outside the unit circle, right, then system is unstable.
Contradiction.
No, there is no contradiction. There are chances that if we use, what is the meaning of now this? Conclusion क्या है इसका? Conclusion is that if we use forward difference method for mapping S plane into Z plane, a stable system may become unstable. May become. We have to check its stability. If we are applying this method, this criteria, then we have to go for stability analysis. Maybe jury stability criteria you can apply after discretization. While in the previous one, backward difference method, if the stable system we are taking, then there is no need of checking stability again, system is obviously stable. This is the difference. Is it clear? Okay.
We should not use this method.
Yeah, student?
We should not use this forward difference method.
No, that is why generally backward difference method is used, because nobody is interested that first check the stability of continuous time system, then again check the stability of discrete time system. So, it is better to use backward difference. That is why mostly problems given in your problem sheet are based on backward difference method, but there is one method also, that is this one. Clear? Any doubt? So, this method was for derivative terms. Another one is given as rectangular rule for integration. Rectangular rule for integration. Now, again consider a continuous time system y dot t equals to minus a yt plus rt. Now, there is no term of integral here. So, I can take integration of this whole differential equation, then it becomes yt, if any initial condition is there, y0, then minus of a, integral of any value you can write, tau you can write here, y tau plus this is minus, here it will be here na, yt minus y0, that is why I have taken this side. Minus a, yes, it is here, minus a is here. No, see the previous equation was dy by dt, I have taken it right hand side only, yt, that equation was like this. So, I have taken this part at here, right hand side, that is why it is minus here.
Sir, ये a 0 to tau.
T you can take T,
Alright.
no problem.
Sir, ठीक ले लेते हैं, इसको confusion हो जाएगा.
Okay.
You can take it.
Basically, our purpose is to include the integral terms in the differential equation, because this method is meant for integral, rectangular rule for integration. Now, again there are two methods. One is forward rectangular rule for integration, forward rectangular rule for integration. This is given as y k minus 1 t to k t y t dt equals to y k minus 1 t. Basically, our objective is what? We are replacing derivative as well as integral terms by some finite difference approximations. In previous method, we have replaced derivative terms. In this method, we are replacing integral terms, right. So, according to this method, forward rectangular rule, it says that if this kind of integral is there, you replace it by this one, right. And second one is B is backward rectangular rule for integration. According to this, k minus 1 t to k t y t dt equals to y k t. These are the two rules. Clear? Any doubts? Okay. Now, basically है क्या? What is this? So, see here, if it is a continuous time system, then for t in this way, This is called forward rectangular rule for integration. And if we take, suppose this is the a so basically what we are doing, this continuous time system, we have a set of rectangles here. We have a set of rectangles here. So, see here, in forward this is the approach, and in backward this is the approach here. This is the forward way of integration and this is the backward way of integration. Now, again we can derive the mapping here. So, our equation is y t equals to, taking initial condition 0, y t equals to minus a 0 to t y t dt plus 0 to t r t dt. This was our differential equation, right. Now, by putting these limits, I get here y k minus 1 equals to minus of a. Now, this is the integral part. Instead of this, if I am using forward integral method, then I can replace it by y k minus 1 t. T you can write here. Similarly, r t into r k minus 1. Is it clear? Now, you can take Z transform of this equation, do it and then calculate y z over r z. करिए. Then rearrange it in y z over r z. It will give you 1 upon z minus 1 upon t plus a. Solve it. I have taken only Z transform of this equation, right. Then through this equation find out y z over r z. Y z, you can multiply z to every term. So, it will be z minus 1, z minus 1, right, plus a, it will come here and divide by t, t is here, then it will be divided by z minus 1. So, z minus 1 t plus a equals to r z. Again I did in one step.
Yes.
Are you getting this one? Yes, you. You take here, you multiply it by z, right? So it will be z yz minus yz equals to minus a t plus t rz. Now divided by t. Okay. Now take this term in left hand side. So it will be positive, right? Now take yz common. क्या बचेगा? z minus 1 upon t plus a, right? So I will write this one here. Is it clear?
Second step is yt equal to yk minus yk minus 1.
This one? Which one?
Yk minus yk minus 1.
This one? It is limit is from k to k minus 1. That was in our derivative. When we are taking integral here, we have to put limits. So yk minus yk minus 1. Yk, this is yk minus yk minus 1. This is by, this we are getting by putting the limits of integral. Is it clear now? Okay. So now see here. Again the differential equation was our same. So in Laplace transform of that is 1 upon s plus a. That was same differential equation we have taken. So now compare again s, here it will be z minus 1 upon t. Is it clear? Laplace transform of that differential equation 1 by s plus a, and we have taken out yz over rz, that is 1 upon z minus 1 upon t plus a. Now see, compare it. So s will be equals to z minus 1 upon t. Now you can see this is the same result which we have got in the finite difference approximation of derivatives, right? So you can say when we are using forward rectangular rule, we are getting the same mapping, or when we were using forward difference method for derivatives. Is it clear? यही हमें एक्सप्रेशन मिला था उसके लिए भी, सेम एक्सप्रेशन फॉरवर्ड के लिए था ना, दैट वाज टेंड्स टू अनस्टेबल, वही वाला. It means if we are applying here rectangular rule by forward method, then there are again chances of that system in discrete time may be unstable. Similarly, you can derive the same expression for backward rule of integration. In examination, it has been asked directly also that prove that stable region in S plane is mapped directly in S plane in Z plane. So accordingly, if they are asking for backward, then you have to prove that if it is stable in S plane, it is stable also in Z plane, right? So this derivation is also important, and some problems are also based on this derivation. So now second method is with backward rule. Backward rule for integration. Now according to this rule, this is given as integral from k minus 1 t to kt yt dt equals to only yk into t. This is the formula according to this method. Now, put these values in that differential equation. Okay. So, we will get y k minus y k minus 1 equals to minus a. Now, there is integral. Should I write that equation again? Okay. Equation was y t equals to minus a of 0 to t y t dt plus 0 to t r t dt. Now, we are replacing these integrals through this expression. We are using now this rule, backward rule for integration. So, this is by putting limits, then minus a. Now, this one can be replaced by only y k into t here, right, through this one. I have replaced this factor by this one. So, it is minus a t y k plus r k or t r k. It is not t 1, it is t r k. Now, again taking Z transform, Z transform of the equation y z minus z inverse y z equals to minus a t y z plus t r z. Now, rearrange again this equation, again divide by t here. Okay. So, 1 minus z inverse upon t plus a, I think. Okay. So, y z taken out, 1 minus, here it is z inverse plus a t equals to t r z. Now, divide by t also, it will be 1 minus z inverse upon t plus a y z here equals to r z. So, y z or r z will be one upon 1 minus z inverse upon t plus a, and Laplace transform of that continuous time function is 1 upon s plus a, that is equals to y s upon r s. Now, see the mapping again, s equals to 1 minus z inverse upon t plus a, no, only t, that is same as we did it for derivatives, backward derivatives. So, it is stable, right. Now, this mapping can be asked in examination in addition to numerical problem. Now, next principle of discretization is the bilinear transformation. Next method of discretization is the bilinear transformation. And this is also called trapezoidal rule for integration. trapezoidal rule for integration. According to this method, in previous one we have sampled in rectangles. Here it is like in trapezoids, like this one. Like this 0 t, 2 t, 3 t, in this way. And the equation for this is k minus 1 t to k t y t dt. This can be replaced by half of y k plus y k minus 1 of t. This is the trapezoidal rule for integration. Now again taking the same differential equation, that is y t equals to minus of a 0 to t y t dt plus 0 to t r t dt. Now we can write y k minus y k minus 1 equals to minus a by 2 y k plus k minus 1 t plus, now this for this one r t again half r k plus r k minus 1 into t. Is it clear? This is bilinear. Now take the Z transform of this equation by taking Z transform. I can write yz minus z inverse yz equals to minus a by 2 yz plus z inverse yz into t plus half rz plus z inverse rz into t. Now we arrange in yz over rz, that is gz equals to yz over rz. Take the terms of all yz to LHS and rz here. Yz over rz, it is coming out t by 2 1 plus z inverse upon 1 minus z inverse plus at by 2 1 plus z inverse. See here 1 plus z inverse into t by 2, this is numerator coefficient of rz, and for denominator this is 1 minus z inverse plus a by 2 t 1 plus z inverse. Is it clear to all?
Yes.
So divided by t by 2, so it will be, and divided by 1 plus z inverse also. This whole term can be divided, so it will be 1 upon 2 by t z minus 1 upon z plus 1 plus a. Is it clear? Divided by this 1 plus z inverse, so it will be 1 minus z inverse upon 1 plus z inverse here, and it will be here only a t by 2. If we divide t by 2 also, then here it will be 2 by t, right? Now it will be z minus 1 upon z plus 1, right. So it is coming out as S. Yz over Rz equals to 1 upon 2 by T into z minus 1 upon z plus 1 plus A. Is it clear so far? Any doubt? Now this is S. So we can write S equals to 2 upon T z minus 1 upon z plus 1. So this is a mapping of S plane to Z plane when we are using trapezoidal rule for integration, or it is also called bilinear transformation. Stability we have to check, otherwise system is unstable, then what is the meaning of discretization? So we have got the relationship between S and Z here. S equals to 2 upon T Z minus 1 upon Z plus 1. Now stability analysis. For this bilinear transformation, and we know that real part of S should be 0, then real part of this S for 2 by T Z minus 1 upon Z plus 1 less than 0. It means, and we know that take the complex variable Z equals to alpha plus J beta. Then we can write here real part of alpha plus J beta minus 1 upon alpha plus J beta plus 1 less than 0. Now we have to separate out real and imaginary parts here. So multiply this by conjugative alpha plus J beta minus 1 alpha plus 1 minus J beta upon alpha plus 1 plus J beta and alpha plus 1 minus J beta. So real part of this is to be calculated, right? So have you solved it?
Yeah.
What is the value of this? Alpha square minus 1 plus beta square less than 0. Then alpha square plus beta square less than 1, right? And this is a equation of a unit circle. Now what is the conclusion from stability analysis? That in the bilinear transformation, if we map S plane into Z plane through bilinear transformation, the whole left hand side including imaginary axis is mapped into a unit circle completely. So we can say that if the system is stable here in continuous time, it will be stable here in discrete time also, right? So this is the method bilinear transformation, and this is also called trapezoidal rule for integration, right? Now there is one problem based on finite difference approximation of derivatives, which is very much important. Let us have one problem which has been asked by in examination. See the problem number 2.25 in your problem sheet. A PID controller is described by ut equals to kc et plus 1 upon ti 0 to t et dt plus td d by dt et. This is the equation of a PID controller. This is given in your problem. Also given that obtain the PID control algorithm by the discretization of the equation. We are not to discretize this equation. We are said to describe this one u dot t. U dot t means derivative of this equation is given as kc e dot t plus 1 upon ti et plus td e double dot t. E double dot means second order derivative. This is given in question that obtain the PID control algorithm by the discretization of the equation of this equation using the backward difference approximation of derivatives, and also find the transfer function uz over ez. Hey problem? Now see here, if we apply the transformation methods in this equation, we need two methods, one for integration term, one for derivative term, right. There is one question in your solved problems that is using two methods. When we have taken derivative of this equation, now there is no integral term here. That is why in this question it is written that using only backward difference approximation of derivatives, because now in this equation there is only derivative terms. Is it clear?
Right.
Why it is written? Now solution. So E derivative of et can be written as using the backward difference approximation, that is d by dt et t equals to kt ek minus e k minus 1 upon t, and second order derivative d2 by dt square et t equals to kt. It will be e dot k minus e dot k minus 1 upon t. Now further it is to be write as t is taken out. Now e dot k is this one. So e k minus e k minus 1 upon t, now minus e k minus 1 minus e k minus 2 upon t. Is it clear? Double derivative. Now solve it. 1 upon t square, t is taken out, e k minus 2 e k minus 1 plus e k minus 2. This is the expression for e double dot t. Now from this equation, now apply this method, backward difference approximation method, apply to this whole equation. So it will be uk minus uk minus 1 upon t equals to kc ek minus 1 upon t plus 1 upon ti ek plus td upon t square. Now put this expression here, E double dot t will be this one. Is it clear? Are you getting?
Yes.
Okay. So it will be ek minus 2 ek minus 1 plus ek minus 2. Now it can be written as uk minus 1 equals to kc ek minus 1 we have multiplied by t, okay, plus t upon ti ek plus td upon t ek minus 2 ek minus 1 plus ek minus 2. Or this can be written as uk minus 1 equals to kc. Now collect the terms ek at one place. So it will be 1 plus t upon ti plus td upon t ek. Clear? Minus then ek minus 1, ek minus 1 is here and 1 is here. So it will be 1 plus 2 t td over t. ठीक है, एक यहाँ है एक यहाँ पे है. And next is plus e k minus 2 into td over t. बस हो गया सॉल्व. नाउ टेकिंग जेड ट्रांसफॉर्म. Now by taking Z transform, uz minus Z inverse uz equals to kc 1 plus t upon ti plus td over t Ez minus Z inverse Ez 1 plus 2 td over t plus Z inverse Z minus 2 Ez into td over t. Is it clear? Now uz equals to, it is 1 minus Z inverse kc or you can divide now 1 minus z inverse to this one, right. So, divide it. So, finally, write expression for uz. For writing the expression uz, we have to divide by this factor 1 minus z inverse, right. So, I am writing here Kc 1 plus T upon Ti plus Td over T into 1 upon 1 minus z inverse. Then minus z inverse upon 1 minus z inverse 1 plus Ez we have taken out
2 TD upon
1 plus 2 Td
upon T
upon T
plus
plus
Z minus 2 over
z minus 2 upon 1 minus z inverse
into TD upon 2
into Td over T and Ez. Now multiply this term to all. It will be Kc 1 upon 1 minus z inverse plus T upon Ti 1 upon 1 minus z inverse plus Td upon T 1 upon 1 minus z inverse minus z inverse upon 1 minus z inverse minus 2 z inverse upon 1 minus z inverse into Td over T plus z minus 2 1 minus z inverse Td over T Ez. Is it correct?
सर इसमें यूजेड अपॉन ईजेड निकालना है,
uz upon ez.
ईजेड निकालना है.
Now Kc 1 upon 1 minus z inverse. Now collect the terms T upon Ti and this is only single term, but these are having Td upon T are having 2-3 terms. So take the common. So 1 upon 1 minus z inverse plus minus this one minus z inverse upon 1 minus z inverse plus T upon Ti 1 upon 1 minus z inverse plus Td over T. Now take the common 1 upon 1 minus z inverse minus 2 z inverse upon 1 minus z inverse plus z minus 2 upon 1 minus z inverse. Now see, it is 1 minus z inverse, it is 1. So it is 1
Yes.
plus T upon Ti 1 upon 1 minus z inverse plus Td over T. Now see here again 1 minus 2 z inverse minus z to power minus 2, that is 1 minus z minus 1 to the square.
सर अगर सबसे नीचे वाली इक्वेशन में जेड इनवर्स से मल्टीप्लाई कर दें तो फटाफट आ जाएगा.
कर सकते हैं, ठीक है. सो इट इज 1 माइनस जेड इनवर्स, इन न्यूमरेटर साइड इट इज स्क्वायर, राइट. सो इट इज 1 माइनस जेड माइनस. हो गया? इज इट क्लियर? then directly you can write uz upon Ez equals to Kc 1 plus T upon Ti 1 upon 1 minus Z inverse plus Td over T 1 minus Z inverse. This is the transfer function representation of the PID control algorithm. Now, we have written only this, otherwise you can see Z upon Z minus 1, but see in answer, see the answer of problem number 2.25, answer is given in this form. You can match the answer of this problem, question 2.25. So, answer is given in this form, right. So, this is all about transformation principles of discretization. So, we have seen about finite difference methods, rectangular rule for integration and bilinear transformation. Anybody, any query? Okay, thank you.